We are Team 4. I'm Jared Adkins, the sole member of the Control Subassembly.
I'm George Santiago, Mechanical Subassembly.
And I'm Alejandro Khalifa, Mechanical Subassembly.
The current state of the DSTR project. The DSTR project is currently in the state of reaching completion, as seen in Figure 1, 2, and 3. However, there are still a few more issues to resolve. Mechanical Subassembly. Both of these pictures were taken during our first initial work day for fabrication at the EIC Center. As seen on the left, we are drilling holes into the metal bars, and as seen on the right in Figure 5, the bars being cut to measurements that were given to us from class.
The project currently has all the items that the Mechanical Subassembly lists that are completed and attached. As you can see in Figure 6 on the left, the metal bar shows the measurements that were given, and on the right in Figure 7, you can see the halfway point of the completed DSTR that you saw in one of the earlier slides. So, some important lessons learned from this project. Safety. Safety is probably the most important rule that you can follow when working on any project. You must always make sure to take precautions when handling and using tools necessary to design and build your project. Plan. Plan before you act. Good proactive planning before you begin working will do wonders to prevent any unnecessary mistakes. Check your work. It is essential to check your work. Double checking and perhaps triple checking your measurements before machining can potentially save the project from suffering from any catastrophic failure later on. And finally, proper procedures. It is good that we have learned the basic way to handle power tools and the proper etiquette when handling them.
For the control team to start, I learned how to strip wires and effectively solder them together, followed by adding and heating heat shrink over the joints. In the two pictures, you can see me soldering and using the heat gun on the heat shrink. My next step was to apply these new skills and my knowledge of Energia and the project as a whole to wire everything together. In Figure 10, you can see the progress that had been made after all of the soldering and heat shrinking had been completed. Figure 11 shows a proper wiring setup for the DSTR build, which I essentially remade more cleanly on the vehicle in our final product. In addition to the wiring, I've made the majority of the changes to the Energia and MATLAB codes that allow the robot to function properly. These changes are not complete, but the code reaches its final stages right now. An issue we've struggled with seriously is Wi-Fi strength, which made our run in round 2 of competition a disaster, but we've tried many other things that have helped with this issue slightly. During my time working on this project, I've become remarkably better at soldering and stripping wires, although this is something I had done in the past. I learned that testing things before you put them all the way together is very important, because there were many times I forgot to test things and ended up having to cut, restrip, and resolder wires. For the same reason, it's a good idea to make absolutely certain that you should do what you're doing before you do it, which has gotten me in the habit of double and triple checking everything I do.
So, as the title said, these are 3 videos from our project demonstrations. The first video shows our very successful attempt at the demonstration where we went to top 10
Quick with the legs, quick with the legs.
Wow.
The second video documents one of the issues that we were talking about in the project, which is the Wi-Fi.
Set, go.
As you can see, we have a solid start, and coming up the Wi-Fi starts to become very weak, and at a certain point it disconnects and the car crashes. The third video was our second attempt at round 2 of the demonstration, in which the same problem occurred as the last video. The Wi-Fi disconnected and the car crashed.
Set, go.
Conclusion. In summation, the project is currently reaching its final phases of completion. The project has all mechanical subassembly parts attached, including the motors, the H-bridge, a working launch board, and has passed the last few demonstrations. The project passed the last demonstration as top 10 in terms of time for Section 510. The only components left of the project to influence are the code, the issue of the Wi-Fi being too weak, and improvements to the mechanical assembly, specifically the battery pack.